Hi, welcome back to the basics of ventilation. This is the second part of the three series. I hope you have watched the first part because this is going to be a continuation of the first part. As I said before, this is mainly for the non-ICU staff because they might get involved in case of an overflow of cases. So we had enough time. Failing to prepare is that you are preparing to fail. In this section, I will be covering in two topics or 2 points. One, you have to know your ventilator and circuits. And second, you have to know the common troubleshooting and how to manage it. So coming to the ventilator and circuits, a basic knowledge of ventilator and circuit is very necessary because when things gets busy, getting help might take some time. So if you have a basic idea of ventilator and circuit, this is going to help you. In our hospital, we are having four types of ventilator. We are having air liquid, we are having GE CareScape, we are having MACVET, and we are having GE Engstone. So in the wall, we are having this outlet. So this outlet is mainly we are having point for the gas and point for the power point also, power plug also. Coming to the gas section, we are having port for 2 oxygen, 2 air and 2 vacuum. So in case one port doesn't work, you can use the other port. But in some areas, we are having 2 oxygen, but 1 air and 1 vacuum. So make sure that which area you are working and what are the facilities is available. Oxygen is having a particular shape, a hexagonal shape. This is mainly a safety mechanism so that the knob of the oxygen hose is also having the same shape. In case of air, it is going to be a square shape and the hose of the air is going to be a square shape. So it's kind of safety mechanism to prevent inappropriate connection. The plug point, we are having a 220 or 240 volt there, which can be used to connect the ventilator. And here we can see the inlet for the oxygen towards the circuit to the ventilator. So how to switch on the ventilator? Each ventilator is having a different mode. In MACVET, we are having a safety closure. So first we have to remove the or open the safety closure. After opening the safety closure, we have to turn on the switch. But in case of GE, whether CareScape or Engstrom is going to be simple. You're having a switch here which you can directly turn on. But when you come to air liquid, you will be having a green button here. To turn it on, you have to press it. But to turn it off, you have to give a long press. Second thing, we have to know our circuit. This is very important because one of the main aim during COVID ventilation is that we want to minimize unnecessary disconnection and we want to minimize unnecessary aerosolization because these two procedures will increase the viral load towards the ICU. So we have to pre-assemble our circuit. We have to make our circuit ready before going for intubation. So the total circuit mainly contains of 5 parts. One, you need a circuit, and this circuit is going to be circuit with MDI port. So that whenever you want to nebulize the patient, you can use the MDI port. No need of going for regular nebulization. This will reduce the aerosol. Second, if you use ETU adapter. So most of the circuit will be having an ETU adapter. So you will come across it and you will know what is the carbon dioxide level of the patient in a roughly manner. And you will be having a filter which is a bacterioviral filter which is capable of catching most of the bacteria and virus. And some of them act as HME filter also. The most important thing is the closed suction. Closed suction is a device where you can do suction without disconnecting the ventilator circuit. So this will prevent the aerosol generation and you will be having an extension. Most of the time it comes as a part of the closed suction. So once again, you're having a circuit, you're having an ETU adapter, you're having a filter, and you're having closed suction with extension. So how to arrange this? Get your ventilator circuit, then connect your EtCO2, then connect your filter, then connect your closed suction apparatus with extension. And this part goes towards the endotracheal tube. So this is how we are setting the ventilator. We have connected the oxygen as well as air. We are having a plug point for the ventilator, and this is the assembled circuit which is connected towards the ventilator. So once again, we will connect the oxygen, air, we will switch on the plug and we will connect one end towards of the ventilator tubings towards the ventilator, and other end we will keep it assembled and will be connected to the patient once he is intubated. So what is the initial ventilator settings? I'm not going in detail. Last class we have discussed about the ACVC mode. So a rate of 15, tidal volume of 6 to 8 ml per kg. Start with a FiO2 of 100. You can titrate according to the situation. PEEP, start with 5 and most of the time you have to increase it. Another thing is that you have to know the display screen of a ventilator because each ventilator is having different display screen. This is how our CareScape GE looks. This is how our Engstrom GE ventilator looks. This is the display of the air liquid which you are having. And this is the display of the Macut ventilator which we will be having. So I will be discussing things in detail about the Macut ventilator because most of the ventilator we are having is going to be the Macut ventilator. So in Macut ventilator we are having mainly 4 modes, 4 to 5 modes. So we were talking about the volume control modes. Once you select the volume control modes, there are a lot of things to adjust. We will stick to the basics. There is a tidal volume around 6 to 8 ml per kg. Respiratory rate will keep something around 15. PEEP we will start with 5 and titrate it. And oxygen we will start with 100 and adjust according to the patient's condition. So this was the graph which I explained in the last section. We are having time in the x-axis, we are having pressure in the y-axis, and this is how the graph looks when you are starting the ventilator. You are having a high pressure which is known as the P peak pressure. You are having a P plateau which is actually the pressure which shows as a constant in the inspiratory hold, and this difference is going to be your PEEP. So we are having P peak and we are having P plateau. How does it look in the ventilator? Here you can see the P peak is something around 23 here. He has shown the value here, and this corresponds towards this tip of the pressure time curve. Pressure time, and this is the P plateau which is around 18 here, and you can see this corresponds towards the plateau form here. So this is going to be a peak pressure, this is going to be a P plateau pressure which is mentioned here 23 and 18. And one thing to keep in mind, we are having an VTI here. VTI means tidal volume in inspiratory. In our patient we have set a tidal volume of 450, and we can see that the inspired tidal volume is almost the same, is going to be 449 in this patient. And keep this in mind, we are having one more tidal volume, that's the exhaled tidal volume which is around 425. A difference between 50 between the VTI and VT is acceptable, but if you are having a very great difference between the VT and VT, you have to always think of leak. And we are having the minute ventilation inhaled and exhaled minute ventilation. So now I told you about the circuits, I told you about the ventilator, and I told you about the display. So we'll come to the common troubleshooting areas. So common troubleshooting areas is mainly whenever you hear an alarm, you have to address it. There are mainly 2 rules. Never turn off the alarm. Second, you assess the patient, not the alarm. So coming to the first alarm is the high peak pressure, or some ventilator it is high airway pressure. So what does it mean? How does it look? This is a scenario where we can see the small video. You can see here the alarm showing high airway pressure. The P peak is high. The graph has changed its shape. And we are having change in VT and VTE. So I have taken a screenshot here. So what we can see is that point number 1, we are having a high airway pressure, which is actually the alarm. And we can see that the graph has changed with a sudden spike. Other thing is that the peak pressure is 40 because we have set a limit of 40. It cannot go beyond 40. So what is happening to the patient? The patient is getting a inspired tidal volume of only 58 and expired tidal volume is only 63, despite of adjusting a tidal volume of 500. So this alarm says that you have adjusted a tidal volume of 500, but your peak airway pressure is so high that the patient is not getting the given tidal volume. So this patient is getting hardly 60 ml inspiration expiration. So this is going to harm your patient. And again, we will be having a reduced minute ventilation also. So I'll go to the video once again. We can see the graph is suddenly changing to spikes. We are having alarm of high airway pressure. We are having high peaks. And if you look at the VTI, VTE is very much reduced. So your patient is not getting enough ventilation and probably he is going to crash if you are continuing ventilation like this for some time. So high airway pressure, change in the spike of the graph, high peak pressure. Most importantly, you will be having very low tidal volume despite of setting of tidal volume of 500. And after some time, probably you will be getting one more alarm, the same scenario, saying that you will be having expiratory minute volume low. So here the minute volume is also low, and you can see the tidal volume is also low. So this is an alarm showing high peak pressure. Now whenever you're hearing an alarm like this, you have to think what are the possibilities. So as I said in the previous description, we are having P peak and P plat. And P peak is basically the airway resistance, which is the endotracheal tube, your trachea, the main bronchus, the circuit, and as well as the filter. And P plat is mainly the pressures in the alveoli. So if you are having a very high peak pressure than the P plateau, the problem is always going to be in your airway resistance. Can be a bronchospasm, then you have to give bronchodilator. It can be some secretions, then you have to suction the patient. It can be a problem with your circuit, the patient biting the ET tube, or a filter getting blocked, or maybe some secretion of mucus plug which is coming in the airway. Second scenario is that you will be having a high peak pressure. At the same time, you will be having a high P plateau, and the difference between the P plat and P peak is less. I will explain it. So this was the graph again. Here we are having a high peak here. We are having a P peak here. We are having a P plateau here. And this is the difference between the P peak and P plat. In the last scenario, what happens is you will be having a very high P peak. This has increased. Your P plat has also increased. And the difference between the P peak and P plat has also decreased. So the problem is going to be with the alveoli, which is affecting your airway also. So it can be secretions which is increasing inside your alveoli going to the airway, can be a case of pneumothorax also. Coming to the next alarm is a low oxygen concentration. So whenever you are having a low oxygen concentration, this is how the screen appears. So you will be having an alarm here saying that your oxygen concentration is low, and despite of setting a FiO2 of around 60, your patient is getting only 26%. So you have set 60% in your monitor, but your patient is getting only 26%. So what can be the reason? One, it can be a leak. It can be a disconnection of your pipe or hose. If so, you try to reconnect it. It can be a problem with the center supply when they are changing the main supplies. You inquire with the biomedical department, inform them and ask their help. If you are using a portable ventilator with a cylinder, always check the pressure, and if required, change the cylinder. So if you are having low oxygen concentration, think about leak and the supply problem. So coming to the next alarm, this is the third alarm, is a low expiratory volume or the expiratory volume low. So I will show you a scenario. So I have taken a screenshot. The main changes are: one, you are having an expiratory minute volume low. Then we have to search for the answer. You check the P peak, it is not very much raised. So the P peak is not the reason why the expiratory minute volume is low. You check the graph in the volume which is abnormal. Most importantly, you can see that the VTA is 496 and tidal volume is 500, that is fine. But the exhaled tidal volume is 62. That means despite of giving a tidal volume of 500, the amount of air coming back to the circuit, coming back to the ventilator is only 62. So again, we can see that the expiratory minute volume is low here. This is another scenario where we can see that tidal volume is around 500, that's what we set, but the expiratory minute volume alarm is on, and you can see that your minute ventilation as well as VTI is very high and VTE is very low, almost zero. This is basically a case of disconnection. So I will show the video to you once again. Now graph is okay, everything is fine, VTI, VT is low. Suddenly the graph changes, alarm comes, and what we have shown here is the difference between the VT and VT, 497 and 110. So there is some leak somewhere. You can see the alarm coming, expiratory minute volume low. So keep this in mind, we'll try to find what are the reasons for it. So basically it shows you are having some leak. So in ventilator circuit, we are having lot of area for leak because lot of connections are there. You have to check your ventilator tubings at the ventilator end. Check all the ports, including the MDI port is working properly or whether it is open or whether it is having some leak. Check your ETCO2, check your filter, any breakage is there, and make sure that your assembled circuit is working properly, especially the closed circuit is working properly. It can be a problem with the endotracheal tube. It can be a disconnection at the adapter end, or it can be a leak at the cuff where you are not able to inflate the cuff properly, so the air will be leaking through the cuff. Next alarm is apnea alarm. Usually it doesn't appear in volume control ventilation very commonly unless otherwise you come down on the respiratory rate. It's mainly seen in weaning mode like pressure support. So if you're having apnea, problems can be over sedation. Try to stimulate your patient or decrease the sedation. Or patient is having weakness or paralysis, so you stop the sedation, reset to the volume control. Other problems like hypoventilation can also affect the patient. So whenever you're seeing an apnea mode in the weaning, apnea alarm in the weaning mode, take care of the sedation, paralysis, or other causes. So you have to remember mainly four things at least. One, if alarm is there, if the ventilator is there, or the patient is crashing in the ventilator, think of displacement of endotracheal tube, think of obstruction of the endotracheal tube. It can be an equipment failure, or maybe it can be a case of pneumothorax. Thank you.